Okay, and then so for the last part, this last part is more conceptual. And so again, we're talking about the same equilibrium, so magnesium fluoride, where we have Mg, F2, solid. We have an equilibrium conditions where we have the Mg2 plus and 2F minus. Okay, so we still have an equilibrium position here, but we've changed the temperature. So if you change the temperature, you're going to change the equilibrium constant, the value for KSP. It's going to shift this equilibrium in a different direction by having a temperature. And so anytime they ask us, you know, about endothermic or exothermic, when we're talking about equilibrium, we need to think about which direction this is going to shift. Okay, so if the concentration of Mg2 plus is at this 27 degrees Celsius, so it's saturated, it's at equilibrium, it's 1.17 times 10 to the negative third. Back on the first part of the problem, our equilibrium concentration for that was 1.21 times 10 to the negative third. So from going from 18 degrees Celsius to this, our magnesium concentration has decreased slightly, meaning we've shifted our equilibrium into the left. Okay, and so this is a Le Chatelier's principle issue here. And again, when we're talking about Le Chatelier's principle with temperature, how that affects equilibrium, we can think of heat as a reactant or product depending on if it's, you know, endothermic or exothermic. Okay, so if we shift our equilibrium to the left after we've increased the temperature, that means heat is like a product here. So we have some heat over here. Okay, so by increasing this temperature, this heat, we're shifting our equilibrium back towards the reactant side and decreasing the concentration that we have of magnesium 2 plus when we're at equilibrium. Okay, and so since heat is a product side, that means by doing this we're going to give off heat. This is going to be exothermic.